find the radius of this sphere for which value of area and volume is same. It's given. Value of the area and the value of the volumes are same. It's given in the question. Area. What is area? 4 pi r square. What is the volume? 4 by 3 pi r cube. 4 pi will get cancelled. R square and this r will get cancelled. One of the square will get cancelled. What is remaining is only r. So therefore r, and this 3 is there, right? Get this to the left. So therefore r is equal to 3 units is the answer, and the choice is option number 2. Isn't it an easy question? Yes. So for which you should know the formula. Area, volume, all this, by heart. Okay. So practice these questions, revise, read. Any number of times, you can watch that link or the video there, and then so that you can revise these formulas. Okay. All right. These are all very basics, which are very, very essential to make the physics subject very strong. Okay. Right. So I'm going to solve one more question, one more illustration. 27 identical liquid drops. So n is a 27. N is the number of drops of liquid. 27 identical liquid drops, each of radius r. So there is a drop of liquid, and I'm going to consider its radius to be equal to r. It's given, small r. Okay, are fused to form a larger drop. What do you mean by fused to form? If I take one drop, to that I'm going to add one more drop. Again, I'm going to add. So I'll go on adding the drops one after the other. When I do that, I'll get a larger drop, right? So many such drops are added to form a larger drop of radius r. Then find r by r. See, this concept is similar to that of the moon and the earth. So when I take one drop, and then when I go on adding many drops, I'll get a larger sphere. So what I have to equate basically? What I have to equate is volume of the larger drop is equal to n times volume of a smaller drop, correct? Volume of larger drop is equal to n times the volume of smaller drop. Okay, what is the volume of the larger drop? Volume of the larger drop is 4 by 3 pi r cube. I've taken capital R as the radius. Then there is n. Okay. Into volume of smaller drop. What is the volume of smaller drop? 4 by 3 pi r is the radius of the smaller drop, r cube. So 4 by 3 pi will get cancelled. So what remains is r cube is equal to n into r cube. So let me rearrange this. Okay, I'll get r cube by r cube is equal to n. R cube by r cube is equal to n. Now that is same as writing r by r cube is equal to n, right? R by r, because the power is same. So we can write within the common power. Okay. So now what is r by r? Now r by r here, when you shift 3 to the other side, it becomes a cube root, n to the power 1 by 3. It becomes cube root of n. See, if that is x square is 5, when you shift the square on the other side, it becomes to the power half. It becomes square root. So similarly, when there is a cube, when you shift it to the other side, it becomes a cube root. Okay. Right. Now what is n? N given as a 27. What is cube root of 27? It's a perfect root, right? Cube root of 27 is a 3. Right? Because 3 cube is a 27. So therefore cube root of 27 is a 3. And we have found capital by small r is equal to 3. But what is the question? The question is small r by capital R. So we have to find r by r. Capital R by small r is 3. What is the small r by capital R? It is 1 by 3. So therefore the answer is not 3, it is 1 by 3 is the answer. Okay. Understood? So again a simple question, but not easy to solve unless you understand what exactly this calculation involves. So therefore improve your again the basic mathematics. This is a very, very useful. And let's see one more structure. Okay, so here we have another structure. What is this structure? This is a triangle. In a triangle, this is the base of the triangle, B. This is called the height of the triangle. So what is the area of the triangle? The area of the triangle is half into base into height. Half into base into height. We have another structure. What is this? It's parallelogram. You know, parallelogram is nothing but combination of two triangles. You can check this. See, this is one triangle here. This is an again identical triangle. Correct? And since there are two such triangles are there, this is the height h. This is the base. Isn't it one triangle? So what is the value of one triangle? One triangle is half BH. That is one triangle. Similarly, there is one more here. So you add them. It's half BH. Correct? So one is half BH for the first triangle. So this is the first triangle, right? So this is the first triangle. Half BH because it's a triangle, area of the triangle. So again for one more plus half BH. So what is the total? The total is half BH plus half BH is nothing but B into H, and that is the area of the parallelogram. So area of the parallelogram is nothing but B into H. Where what's B? B is the base, or it's one of the side. What is H? The perpendicular distance is called the height. So BH is the area of the parallelogram. So let's check one more structure, which is trapezium. It's called trapezium. In trapezium, first you have to identify the parallel sides. Which are the sides which are parallel? So here, this is one of the side, and this is the other parallel side. I'm going to write it as A and B. A and B are the two parallel sides. Here, where is the parallel side? So this is one side and this is the other. So one is A, other is B. So first identify the sides which are parallel. Okay. Then the perpendicular distance between these two parallel sides is taken as the height h. See, here it is. This is h. So this is one side, this is the other side, and this is the perpendicular distance between them, h. Similarly, here this is A, this is B, and this is H. And now the area of the trapezium is equal to half into H, which is the height, and then sum of the parallel side, which is A plus B. A is equal to half into H into A plus B. Clear? So that's the area of the trapezium. It's half into height into sum of the parallel sides. Okay? Right. Next, let's solve one example to understand how we can apply this formulas to the various structure. Okay? Right. So the question is this: find the area below the y-axis graph. So that is a graph. This is a graph. graph given. Okay. So we have to find the area below it. Now when I say area below it, I have to find this area. This area. So what I'll do is, I will split this into two parts. First, I will find the area of only this structure. Only this. Okay. What is that structure that I have marked, shaded? That's nothing but a trapezium. So let's find. Area is equal to. In that, first identify which are the parallel sides. So one parallel side is this. This is one parallel side. To that, first note the value here. So this is a 2. See, it's a 2 here. And this edge I wanted. For this is 7. Okay. So this is 2 and this is 7. For the other parallel side, here it is 0 and the other value is 8. So, how to find the area? Area is equal to half into height. Height is nothing but this, distance between the two parallel sides. How much is that? See, here it is 0 and this value here is nothing but 2. 0 and then 2. So 2 is the height of the trapezium. How much is that? 2 minus 0 is a 2. So therefore it's half into height, which is 2, into sum of the parallel sides. So what is the value of one of the parallel side? One of the parallel side is here. 7 minus 2, because we have to find this length. No, so 7 minus 2. 7 minus 2 is 5. And 8 minus 0 is 8. So we have just now found, this 2 will get cancelled. We have found only the area of the trapezium. Now the remaining area is pending here. Now this area is pending. First let's see what is the value corresponding to that structure. Okay, right. So based on this here, to find the height, this is 3 and this corresponds to 2. This is 3, this is 2. How much is this length? Whatever the size given, that's 1. 3 minus 2, see, from 2 to 3 is 1. Now I have to find this side. How much is this here? It's a 4. 4 here. On this side it is 6. So what is the difference? 6 minus 4 is 2. So this difference here is 1 and this difference here is 2. So one side has value 2, the other side has value 1. And how do you find the area of it? It looks like a square here, but based on the value it is not a square because this is 2 and this is 1. In any case, how do you find the area of a square or a rectangle? Multiply length into breadth. So 2 into 1 will give you 2. So that's what I'm going to add here. So 8 plus 5, 13, 13 plus 2 is 15. So 15 is the area below this particular graph. Understood this? So we have used the formulas of area of the trapezium, we have used the formula of the rectangle. So this is the applications, students, in various graph, in various concept, in various topics. Okay. So revise these formulas thoroughly and make sure you know these formulas by heart. Okay. Right. So let's see if there is any other formula which is remaining waiting. Okay. So we have another structure which is a cylindrical structure. So what is the area of the cylinder? The area of the cylinder is, if you see only this portion of the cylinder, that's a circle, right? See, this portion is circle. So what is the area of that circle? It's pi r square. But cylinder is like many circles placed one above the other, correct? You take one circle, place one more circle above it, place one more circle. It's like, how we place plates one above the other, circular plates, one above the other. That will give you a cylindrical structure, isn't it? So, for one, it is pi r square. There are many such circles stacked one above the other, having length L. So therefore, or you can even write H. So it's pi r square into h will give you the total area of the cylinder, pi r square into h. Are you clear? So pi r square is the area, correct? Pi r square into h is the volume. The area is nothing but the area of that is circumference, which is 2 pi r into h. Okay, 2 pi r is the circumference, so that we wanted the surface area, right? Okay, this one. Surface area, okay, lateral surface area. So it is 2 pi r into h. Volume, yes. So that was the volume formula which I had given, which is pi r square into h will give you the volume. Okay, so hope there is no confusion. 2 pi r into h is the area, circumference into the height, whereas pi r square into h will give you the volume of the cylinder. Okay. Right, so we have another structure, which is cube. What is the area of the cube? Area of the cube. A cube has 6 faces, and all the 6 faces are identical. So if I take only one face, it's a square. So if A is the side of the cube, then the area of one side is A square. But how many such faces are there? 6. So 6a square is the area of the cube. Area only. Okay. How about its volume? Volume is nothing but a cube. Okay. Its height and length, correct? Correct. Length, breadth, and the height. All the 3 identical. So that's why we get a cube. We have another structure which is called cuboid. Now, what is a cuboid? Cuboid is a structure in which different faces, have different length. Okay. So let me write. If one is L, if this is the length. If this is the breadth, and if this is the thickness. L is the length, B is the breadth, and T is the thickness. Now, what is the total area of the cube? See, first, for each face, I am going to measure the area. Okay. First, I am going to measure for this surface, L into B. So it's L into B. One face, one. But similarly, there is a face below. So it becomes 2 into LB plus 2 into L into T, length into thickness, plus 2 into B into thickness. Understood? Length into breadth, one face. Then length into thickness, that is here, which is L, that is this face. See here, this one. L into T. Correct? The face, which is nearest, that is the one, which is L into T. Similarly on the other side. And then B into T, that is this face, B into T. Okay. And why we are multiplying by 2? Because there are 2 such identical faces. Total, you can see 6 faces are there. So that's the area of the cuboid. How about the volume? The volume is length into breadth into thickness will give you the volume of the cuboid. So a cuboid is one where the sides are different, and if the sides are equal, then it becomes a cubical structure or a cube. Right. Okay, so let's solve one numerical. A solid metal cube. So there is a solid metal cube like this, metal cube. of side 3.142 centimeter. So side of that is 3.142 centimeter. Is drawn into a thin uniform wire. So a cube made up of metal is drawn into a thin wire like this. Okay, it's hammered and then it's drawn into a very thin wire like this, thin wire. Thin wire, okay. Thin wire of 1 meter. So the length is 1 meter. Find the radius of this wire. What is the radius of this particular wire? So that radius we need to calculate. So if you look at this unit here, this is in centimeter, whereas this length is given in meter. So this first I will do the conversion. How do we convert a centimeter to meter? So what you can do is 3.142. To convert from centimeter to meter, you divide by 100. Dividing by 100 is same as writing 10 to the power minus 2 like this. Dividing by 100 is same as writing multiplying by 10 to the power minus 2. So I have done the conversion, which is now in meter. So A is equal to 3.142 into 10 to the power minus 2 meter. Okay. Length is given, it's 1 meter. Okay. So now here, when this solid cube is converted, or when it is drawn into a uniform wire, volume of the cube is equal to volume of the wire, because the total volume for this cube and this wire has to remain same, because there is no loss of mass, correct? It is drawn into a different shape, so total volume has to be same. So what is the volume of the cube? Volume of the cube is always A cube. What is the volume of the wire? The volume of the wire is, it's a cylindrical wire. Can you see that? Wire means it's a cylindrical. And what is the volume of a cylinder? It's a pi r square into height, which is h. And that height is nothing but same as the length. So it is pi r square into L. What is the value of A? A is here 3.142. But that 3.142 is nothing but pi. See, that's pi into 10 to the power minus 2. Cube of that is pi cube into 10 to the power minus 2 cube is nothing but 10 to the power minus 6. How do we get that? 10 to the power minus 2 cube means multiply this by 3, because that is also cube. Pi cube, and this is also cube, means you have to multiply this by 3. 3 into 10 to the power minus 2 is nothing but minus 6. That's equal to pi r square. Correct? Pi r square. We have to calculate the radius of that wire, pi r square. And then L here, this is L. And L is given, it's 1 meter, L is there, it's 1 meter. So therefore this is into L. Now this pi will get cancelled here, this pi and one of the pi will get cancelled. And what you get is only pi square into 10 to the power minus 6 is equal to r square. So what is the value of r? The value of r is square root of pi square into 10 to the power minus 6. 10 to the power minus 6. And what is the square root of pi square? It is only pi itself. And what is the square root of 10 to the power minus 6? Basically, square root of 10 to the power minus 6 means you divide here by the root. For the root, the value is half. So therefore, divide this by half. You will get 10 to the power minus 3 here when you divide. So that is the radius of the cube, radius of the wire, and that will be in meter. So here, since the value of the cube is given in centimeter, there was a need to do the conversion from centimeter to meter. Okay. So that's how we got the answer as 10 to the power minus 3 meter. Okay, so students, I hope you have understood all the concept that I have explained today. And when the actual topic, when we start, you'll understand where exactly that we are going to use all of these formulas. So practice this and try to answer these questions by yourself. So I will explain one more concept in my next session. Thank you.